In the vast canvas of the universe, stars are the architects of creation, the furnaces where the elements of life are forged. From the familiar glow of our sun to the distant giants scattered across the cosmos, these celestial titans shape galaxies, ignite worlds, and define the destiny of space itself. Yet among them, there exists a monster, a star so colossal, so unimaginably powerful, that its very existence challenges the limits of our understanding. Its size dwarfs everything we know, and the forces it commands are as terrifying as they are awe-inspiring. To gaze upon it is to witness the raw, unrestrained power of the cosmos itself, power that could obliterate entire systems in a single breath. Tonight, we embark on a journey to confront the horrifying force of the biggest star ever discovered. With that said, let us begin. To comprehend the sheer horror of the largest star ever discovered, we must first place it within the hierarchy of the cosmos. Stars come in a staggering variety of sizes. Our Sun, which seems immense to us, is actually rather ordinary, a yellow dwarf, modest compared to the giants that roam the stellar plains. There are red dwarfs, which make up the majority of stars, tiny but long-lived, glowing faintly in the dark. Then there are the blue giants and supergiants, stars burning so fiercely that they shine with an intensity millions of times greater than the Sun. But above them all stand the hypergiants, the true behemoths of creation. The star that holds the crown for sheer size is often identified as Scuti, a red hypergiant located in the constellation Scutum, nearly 9,500 light-years away. To call Scuti enormous would be an understatement. If placed at the center of our solar system, it would extend far beyond the orbit of Jupiter. Its radius is more than 1,700 times greater than the Sun's. Imagine the Earth's orbit swallowed whole, with room to spare for multiple other planets. It is not merely a star, it is a cosmic leviathan. Yet, with size comes fragility. These hypergiants live fast and die young, consuming their fuel at a furious pace. Their existence is a ticking clock, counting down to a cataclysm so violent it could shake galaxies. But before we delve into the terror of its death, we must grasp the forces that allow such a monster to exist in the first place. At the heart of a star lies nuclear fusion, the process that turns hydrogen into helium, releasing unfathomable energy. In ordinary stars like our Sun, this process is balanced, gravity pulls inward, fusion pushes outward, and the star remains stable for billions of years. In hypergiants like Scuti, however, this balance teeters on a razor's edge. Its mass is estimated to be only 30 times that of the Sun, yet its size is over 1,000 times larger. This paradox exists because the outer layers are bloated, tenuous, and unstable, expanding into a diffuse, gaseous envelope that extends across billions of kilometers. If you were somehow able to fly through its surface, you would find no solid boundary, only a gradual thickening of searing plasma that grows denser as you dive toward the core. The surface itself burns at a relatively cool temperature for a star, around 3,500 degrees Celsius, cooler than the Sun's 5,500 degrees. That is why Scuti appears red. But do not be deceived, the total amount of light it emits dwarfs the Sun's output by nearly 340,000 times. Every second, this star releases as much energy as our Sun does in weeks. Yet even this astonishing brightness is just a whisper of the chaos brewing within. The interior is a cauldron of nuclear reactions layered like an onion. Hydrogen fusing into helium, helium into carbon, carbon into neon, neon into oxygen, and so on, each layer closer to the core burning hotter and faster. With every stage, the star inches closer to its inevitable demise, building the fuel for a detonation that will rival the most catastrophic events in the cosmos. The life of a hypergiant is a constant struggle between two titanic forces, gravity and radiation. Gravity wants to crush the star into oblivion, while the radiation produced by fusion pushes outward, resisting collapse. In Scuti and stars like it, this battle is fought on unimaginable scales. The sheer size of Scuti means its outer layers are precariously held. Radiation pressure is so extreme that its atmosphere is constantly boiling off, creating massive stellar winds that expel material into space at millions of kilometers per hour. These winds are so strong that the star sheds enormous amounts of mass over time, surrounding itself with shells of gas and dust. The region around Uy Scuti glows faintly in infrared light, revealing the remnants of its own body drifting into the void. This mass loss is not a gentle breeze but a cosmic storm, stripping away solar masses of material that could one day form new stars, planets, or even life. Yet, the more mass it loses, the more unstable it becomes, hastening its collapse. It is a paradox. The very force that gives the star its brilliance also tears it apart. From a human perspective, these scales defy imagination. A cubic centimeter of Uy Scuti's core, smaller than a sugar cube, would weigh more than 1,000,000 tons under Earth's gravity. The pressure inside is so extreme that atoms themselves are crushed, their electrons forced into unnatural arrangements, sustaining the nuclear inferno. And when this balance tips, when the core can no longer withstand the crushing weight, the horrifying finale begins. The lifespan of stars depends heavily on their size. Small stars, like red dwarfs, can burn for trillions of years, longer than the current age of the universe. Our Sun will survive for about 10 billion years in total, currently halfway through its life. But for Uy Scuti, the story is drastically different. With its immense size and furious energy output, it is racing through its life cycle at breakneck speed. Astronomers estimate that Uy Scuti has existed for only a few million years, and already it is nearing the end of its journey. The clock is ticking because of fuel consumption. Every second, Uy Scuti is burning through staggering amounts of hydrogen, more than our Sun consumes in an entire day. And once the hydrogen is depleted, the fusion of helium and heavier elements begins. Each stage is shorter and more violent than the last. Helium might last hundreds of thousands of years, carbon a mere 1,000, neon only a year, oxygen months, and silicon mere days before the core can no longer support itself. This progression leads toward a climax of apocalyptic proportions. The star is essentially stacking up the elements of the periodic table, forging heavier and heavier atoms, until finally, it reaches iron. Iron is the point of no return. For fusing it consumes energy rather than releases it. At that moment, gravity wins the battle it has fought for millions of years. In cosmic terms, Uy Scuti is a dying giant, its candle burning with both ends ablaze. And when its clock strikes midnight, the universe will bear witness to a cataclysm of horrifying scale. When the core of a hypergiant like Uy Scuti collapses, it does so with unimaginable violence. The inward pull of gravity becomes unstoppable, crushing the core in milliseconds. Temperatures soar to billions of degrees, and shockwaves rip outward. What follows is a supernova, the most powerful explosion a star can unleash. In the blink of an eye, Uy Scuti will release more energy than our Sun will radiate over its entire 10 billion year lifetime. The outer layers of the star, thousands of times larger than our solar system, will be blasted into space at speeds exceeding 30,000 kilometers per second. To an observer thousands of light-years away, the supernova would shine so brightly it could rival the light of an entire galaxy. For weeks or months, the night sky in that region of the universe would be dominated by the dying scream of this titan. But the supernova is more than a spectacle. It is a cosmic forge. In its fiery death, the star produces elements heavier than iron, gold, uranium, platinum, the building blocks of planets, oceans, and even life itself. Without the deaths of such monsters, the universe would be barren of complexity. In this sense, we owe our very existence to the horrifying ends of stars like Uy Scuti. And yet, this is only half the story. Because once the explosion fades, what remains at the core may be even more terrifying than the blast itself. When the fury of the supernova subsides, the fate of Uy Scuti's heart depends on how much mass remains. If the core is relatively small, it will compress into a neutron star, an object so dense that a teaspoon of its matter would outweigh Mount Everest. Neutron stars are cosmic lighthouses, spinning rapidly, sometimes emitting beams of radiation across the galaxy as pulsars. They are among the strangest objects in existence, pushing physics to its extremes. But if the core is too massive, as many suspect in the case of Scuti, then the collapse will continue. Gravity will crush the matter beyond recognition, past the point where even light itself can escape. A black hole is born. This is the ultimate cosmic predator, an abyss in space that devours everything that strays too close. The collapse of Scuti would likely produce a stellar mass black hole, a remnant capable of swallowing entire stars in its vicinity. Around this black hole, the remnants of Scuti would swirl in a deadly accretion disk, heating to millions of degrees, emitting X-rays powerful enough to pierce the fabric of interstellar space. To think of such a monster forming from the death of a single star reveals the terrifying scale of stellar evolution. The universe creates beauty, but it also creates nightmares. And Scuti, in its death, is destined to become one of them. To understand the horrifying force of Scuti, it helps to imagine what it would mean if such a star were placed in our own solar system. If Scuti replaced our Sun, its swollen outer layers would extend far beyond the orbit of Jupiter, engulfing Mercury, Venus, Earth, Mars, and even the gas giant itself. Every trace of our home world would vanish, dissolved into the crushing plasma of a stellar giant. The heat from its surface would scorch the solar system beyond recognition. Planets far from the Sun that are icy and frozen today would become blazing deserts under the radiance of this hypergiant. The asteroid belt, Kuiper belt, and even the far reaches of the Oort cloud would be bathed in light many times more powerful than anything our Sun could produce. For any form of life, survival would be impossible. This mental exercise reveals a truth about the cosmos: our Sun is small, almost fragile, compared to the monsters that dwell among the stars. Earth is lucky, the Sun's stable, moderate energy output has allowed life to flourish for billions of years. If we orbited Scuti instead, we would have never existed at all. Our very existence is tied to the fact that we orbit a star that is not too small, not too large, but just right. Scuti is the opposite of just right. It is an embodiment of excess, a demonstration of how extreme the universe can be when gravity and fusion spiral out of balance. The horror of Scuti lies not only in its eventual death but also in its violent present. The star is not stable, it is losing mass at an extraordinary rate, unleashing stellar winds so powerful they shape the very space around it. These winds eject plasma into the interstellar medium, forming clouds that stretch light-years wide. To measure the power of these winds, astronomers compare them to the solar wind produced by our own Sunday. The Sun's wind affects Earth constantly, producing auroras and shaping our planet's magnetosphere. Yet Scuti's stellar wind is billions of times more intense. Entire solar systems could be stripped bare by its ferocity. Any planet unlucky enough to orbit it would be bombarded by radiation and plasma storms on a scale no atmosphere could withstand. This constant shedding of material creates what can only be described as a stellar shroud. Infrared telescopes reveal vast, glowing shells of gas around Scuti, remnants of the star literally tearing itself apart as it nears its end. Each pulse of material carries the signature of the star's instability, a warning that it is running out of time. In this sense, Scuti is not merely a giant, it is a star in agony, thrashing violently against the inevitability of collapse. And in that thrashing, it reshapes the galaxy around it, seeding space with the elements of creation, even as it foreshadows its own annihilation. Although Scuti is a solitary giant, its influence is not confined to itself. Stars this large exist within galactic ecosystems, and their life cycles play a defining role in shaping their environments. Scuti resides in the Milky Way Scutum constellation, an area rich with star formation and interstellar clouds. It is part of a galactic arm teeming with stellar nurseries, nebulae, and younger stars still taking shape. When such a hypergiant ends in a supernova, the shockwaves expand outward for dozens of light-years, compressing nearby gas clouds. This compression can trigger new waves of star formation. In other words, the death of Scuti will one day give birth to countless smaller stars, perhaps even solar systems like our own. It is both horrifying and beautiful, destruction and creation bound together in an endless cosmic cycle. However, the violence of its death will also sterilize vast regions of space. Any planet within tens of light years will be bathed in radiation capable of erasing all traces of life. Gamma rays from the blast could damage atmospheres, strip away protection, and render entire worlds barren. What for us would be apocalyptic is, for the galaxy, simply a reshuffling of resources, an exchange of matter between generations of stars. In this sense, Scuti is a paradox, both destroyer and creator, a single star holding the fate of countless future worlds in its monstrous grasp. Its neighborhood is not just a backdrop, it is the stage upon which this cosmic drama will unfold. Every moment that passes brings Scuti closer to its inevitable collapse. To us, these timescales may seem vast, thousands or even millions of years. But in the language of stars, Scuti is already living on borrowed time. Its hydrogen reserves are nearly gone, and it has already entered later stages of fusion. Right now, deep inside its core, elements heavier than helium are being forged in rapid succession, each layer burning hotter and faster than the last. The star's outer layers expand and contract in enormous pulsations, causing its brightness to vary. These fluctuations are not random, they are a sign of internal instability. Astronomers monitoring Scuti have observed that it is shedding mass at an astonishing rate, a clear signal that its final chapters are unfolding. At some point in the not-so-distant cosmic future, the star will collapse in a supernova so violent it may briefly outshine every other star in the Milky Way combined. Imagine looking into the night sky and seeing a star flare into brilliance, visible even in the daytime. For ancient civilizations, such a sight would have been interpreted as an omen. For us, it would be a reminder of the incomprehensible forces that govern the universe, and a warning of the fragility of existence. The countdown is ticking, and when the end comes, it will be sudden and catastrophic. When Scuti finally collapses, the event will unleash a shockwave unlike anything Earth has ever witnessed. Traveling outward at a fraction of the speed of light, the blast will sweep across surrounding space, carrying enough energy to sterilize entire systems. Any nearby planets would be vaporized in moments, their atmospheres stripped, their crusts shattered, their cores melted into nothingness. For observers thousands of light years away, the shock wave will not reach us physically, but its radiation will. Gamma rays, X-rays, and high-energy particles will travel across the galaxy, striking everything in their path. Thankfully, Earth is too far to be affected by lethal doses, but any civilization unlucky enough to exist within a few dozen light-years of Scuti would be obliterated. The aftermath of the supernova will fill interstellar space with debris, a glowing nebula of dust and gas, enriched with heavy elements. Over time, this debris may condense into new stars, new planets, and perhaps new life. Yet the sheer violence of the initial explosion ensures that the destruction it leaves behind will be remembered for eons. This duality, life created through death, is the cosmic balance of the universe. Scuti's horrifying end will erase entire regions of space, but it will also plant the seeds of future creation. If Scuti's core is heavy enough, and most astronomers suspect it will be, the aftermath of its collapse will not end with a neutron star. Instead, gravity will crush its core beyond comprehension, forming a black hole. This is where the true horror begins. A stellar mass black hole born from a hypergiant is not a quiet remnant. It is a predator. Gas and dust from the exploded star will spiral inward, forming an accretion disk glowing with deadly radiation. Jets of high-energy particles may shoot from its poles at near-light speed, cutting through interstellar space like cosmic lances. The black hole itself will be invisible, its event horizon swallowing light. Anything crossing that threshold, matter, energy, even time itself, will be lost forever. In a sense, the black hole will be the ultimate tombstone of Uy Scuti, a monument to the terrifying forces that once burned within. Though far from Earth, such an object would shape its galactic neighborhood for millions of years to come. Entire star systems could one day drift too close and be consumed. Uy Scuti, in death, will leave behind a legacy not of brilliance, but of eternal darkness. The horrifying power of Uy Scuti lies not only in its size or its explosive death but also in its role as a cosmic blacksmith. Within its furious core, nuclear fusion pushes matter up the ladder of the periodic table. What begins as simple hydrogen, the lightest and most abundant element in the universe, is slowly transmuted into helium, carbon, oxygen, neon, and beyond. But the true alchemy happens in the final moments of its existence. When Uy Scuti erupts in supernova, the unimaginable heat and pressure create elements heavier than iron. Gold, silver, platinum, uranium, the rarest and most valuable materials in the cosmos, are born in this split-second inferno. Without such stars, there would be no planets with iron cores, no oceans filled with salt, no DNA woven with phosphorus, no civilizations wearing jewelry forged from ancient stardust. Every atom of iron in your blood, every atom of calcium in your bones, was once forged in the heart of a massive star like Uy Scuti. In this sense, we are all connected to these cosmic monsters. They are terrifying in their destructive power, but they are also our ancestors. Without them, life as we know it would not exist. The horror of their scale is matched only by the beauty of their legacy. Ironically, the very thing that makes Uy Scuti terrifying also makes it fragile. Hypergiants are unstable by nature. Their bloated atmospheres are tenuous, stretched thin by radiation pressure. Their lifespans are measured in millions of years, cosmic sparks compared to the long-burning embers of smaller stars. In a sense, they are like fireworks, dazzling, powerful, and brief. This fragility is what ensures their violent end. Unlike smaller stars, which quietly fade into white dwarfs, Uy Scuti is doomed to self-destruction. The larger a star grows, the faster it burns, and the faster it dies. Its vast size is not a mark of strength but of impending collapse. If we could watch Uy Scuti across millions of years, we would see it swell and shrink, shedding its layers like a dying beast, until at last it gives way to the inevitable. For astronomers, this fragility is both a challenge and an opportunity. Studying such stars helps us understand not just how they live and die, but also how galaxies themselves evolve. Hypergiants like Uy Scuti are rare, fleeting, and precious windows into the violent heart of the cosmos. Numbers alone cannot capture the horror of Uy Scuti. Saying it is 1,700 times larger than the Sun, or that it shines 340,000 times brighter, may sound impressive, but our minds struggle to picture such magnitudes. To truly grasp it, we must use metaphors. If the Sun were the size of a soccer ball, Uy Scuti would be a stadium. If our solar system were a modest suburban home, Uy Scuti would be a sprawling metropolis, engulfing entire neighborhoods. Its surface is so vast that light itself would take over 7 hours to travel from one side to the other, a journey that takes just 8 minutes across the span between the Sun and Earth. Yet even these comparisons fall short. The human brain is simply not designed to process such enormity. And this is where the true terror lies. The universe contains objects so far beyond our comprehension that we can only whisper their scale in numbers and metaphors. Uy Scuti is not just a star, it is a reminder of our own smallness. A reminder that the universe is filled with monsters far larger and more powerful than anything we can truly imagine. The Milky Way is home to hundreds of billions of stars, yet only a handful can compare to Uy Scuti in scale. Tucked within the constellation Scutum, Uy Scuti resides in one of the galaxy's most active star-forming regions. Surrounded by dense interstellar clouds, it is part of a vibrant stellar nursery. A cosmic cradle where new stars are constantly being born. In this neighborhood, Uy Scuti is both anomaly and inevitability. Its presence demonstrates the extremes to which nature can push the process of stellar formation. The gas clouds that gave birth to it must have been vast and dense, collapsing under gravity to form a star of incredible mass. But it is also a warning: stars like UY Scuti live fast and die young, and the region it inhabits will one day be scarred by its violent death. Astronomers often compare hypergiants like UY Scuti to natural disasters on Earth: hurricanes, earthquakes, volcanic eruptions, except on a scale that dwarfs entire worlds. The eventual supernova will echo across the galaxy, sending waves of energy that could ignite new stars and erase fragile life in neighboring systems. Within the Milky Way, UY Scuti is a sleeping giant whose awakening will reshape the very fabric of its galactic arm. UY Scuti is not alone in its kind. Other hypergiants, such as Betelgeuse in Orion or VY Canis Majoris, also loom large in the night sky. Each one is a ticking time bomb, nearing the end of its life. These rare stars are cosmic experiments, showing us the limits of how large and luminous a star can become before gravity and fusion tear it apart. For astronomers, studying hypergiants is like peering into the universe's laboratory. They provide clues about how the first stars may have behaved billions of years ago, when the cosmos was young and raw material was abundant. Those primordial stars, called population 3 stars, may have been even larger than UY Scuti, blazing fiercely before collapsing into black holes that seeded the galaxies we see today. Hypergiants are also test cases for the physics of stellar death. By observing their pulsations, mass loss, and spectral lines, scientists attempt to predict when and how they will explode. Every observation is a piece of a puzzle that could help us understand not just the lives of stars, but the ultimate fate of galaxies. UY Scuti, in this sense, is more than an astronomical curiosity. It is a beacon of knowledge, a warning flare from the edge of possibility, teaching us about the destiny of giants. For all the terrifying details we know about UY Scuti, many mysteries remain. Measuring stars of such colossal size is extraordinarily difficult. Their outer layers are not solid but diffuse, blending into space in a haze of plasma. Determining exactly where the surface of a hypergiant lies is more a matter of definition than precision. This is why debates exist about whether UY Scuti is truly the largest star, or if others like VY Canis Majoris or Stephenson 2-18 may surpass it. Depending on how measurements are made, whether using radius, luminosity, or volume, different stars can claim the title of largest. Even so, UY Scuti remains a symbol of the extreme. Its sheer scale, combined with its instability, makes it one of the most fascinating objects in the sky. Adding to the challenge are the dust clouds surrounding it, obscuring its light. Astronomers must rely on infrared observations to pierce through the shroud, and even then, uncertainties remain. These uncertainties remind us that the universe still guards its secrets. Even in an age of powerful telescopes, the cosmos keeps us guessing. This mystery adds to the horror. UY Scuti is so immense, so strange, that even with our best instruments, we can barely define its true shape. It is as if the star itself refuses to be measured, looming in the void as a shadowy titan beyond comprehension. When stars like UY Scuti die, their fury is not confined to themselves. The radiation from a hypergent supernova can travel across light-years, bombarding distant worlds with lethal energy. Gamma-ray bursts, the most violent form of stellar death, are capable of sterilizing entire planets even from thousands of light-years away. Though UY Scuti is unlikely to produce such a burst aimed at Earth, its potential for devastation is a chilling reminder of our vulnerability. For any civilization within its immediate neighborhood, survival would be impossible. The sheer radiation output would strip atmospheres, ignite oceans, and erase biospheres in moments. Planets that may have harbored life for billions of years could be reduced to barren husks in an instant. In this sense, hypergiants are cosmic executioners, their deaths reshaping not just matter but the destinies of entire systems. The Milky Way is vast, and stars like UY Scuti are relatively rare. But they serve as a reminder that the universe is not a gentle place. Catastrophe is woven into its fabric, and the very forces that create life are the same forces that can extinguish it without hesitation. Ui Scuti is a symbol of this paradox, creation through destruction, horror bound to beauty. One of the most haunting questions about Ui Scuti is whether humanity might one day see its end. At nearly 9,500 light-years away, its light takes millennia to reach us. This means that whatever we see today is an ancient version of the star, frozen in time. For all we know, Ui Scuti may have already exploded, and we are simply waiting for the light of its death to reach our eyes. If it were to go supernova tomorrow, the event would not harm Earth due to the great distance, but it would be a spectacle unlike any other. For weeks, the star would shine so brightly that it would rival the moon in our night sky, visible even during the day. It would dominate headlines, inspire awe, and remind humanity of its smallness beneath the stars. Astronomers would study the explosion obsessively, capturing data that could reshape our understanding of stellar physics. For ordinary people, it would be a cosmic fireworks show of terrifying scale, a reminder that even the universe itself has climaxes of drama and violence. Whether we will live to see Ui Scuti's death remains uncertain, but the possibility is enough to send shivers down the spine. Why do we fear stars like Ui Scuti? It is not as if they pose an immediate threat to our survival. Yet the very thought of such titans evokes dread. The reason lies in psychology. Humanity fears what it cannot control, and the scale of hypergiants places them firmly beyond the realm of control. For thousands of years, humans have looked at the night sky and woven myths around its brightest stars. Giants like Betelgeuse or Antares were seen as gods, warriors, or omens. If ancient civilizations had known the true scale of Ui Scuti, they may have regarded it as the ultimate deity of destruction. Today, even with scientific understanding, the awe remains. We have replaced myth with data, but the terror lingers. In many ways, Ui Scuti forces us to confront our fragility. Our entire planet is less than a speck beside its swollen body, and our civilization would vanish without trace if caught in its orbit. Yet it also connects us to the cosmos. The elements in our bodies, the iron in our blood, the gold in our rings, were forged in the deaths of such giants. They are monsters, yes, but they are also the reason we exist. This duality, fear and gratitude, horror and wonder, is what makes hypergiants so haunting. They remind us that the universe is both a cradle and a grave, and that our lives are bound to forces far beyond our control. Hypergiants like Ui Scuti are more than singular curiosities, they are galactic architects. Their short, violent lives have a disproportionate impact on the ecosystems of galaxies. Through their stellar winds and supernova explosions, they inject energy and heavy elements into the interstellar medium, stirring and enriching it. This material, once dispersed, becomes the seed for new stars, new planets, and new possibilities for life. Without hypergiants, galaxies would stagnate. The gas clouds between stars would remain cold and inert, star formation would slow, and planets rich in complex chemistry would never emerge. Every world capable of supporting life owes its existence, in part, to the violent generosity of massive stars. Ui Scuti is a reminder that the universe thrives on extremes. Its life is short compared to smaller stars, but its influence will echo for billions of years after its death. The gas and metals it expels will drift across the Milky Way, one day becoming part of other stellar systems. Somewhere in the distant future, a world may orbit a stable sun, its mountains layered with elements forged in Ui Scuti's inferno. That world might harbor oceans, skies, and even life itself, all born from the ashes of this terrifying giant. While Ui Scuti looms as one of the largest known stars, it is also incredibly rare. For every hypergiant in the galaxy, there are hundreds of millions of ordinary stars. Their rarity comes from the improbable conditions required to form them: colossal molecular clouds, gravitational collapse of enormous scale, and the right mixture of density and turbulence. This rarity makes them precious to astronomers. Each hypergiant we observe provides invaluable insight into the upper limits of stellar physics. They allow scientists to test theories about nuclear fusion, mass loss, and stellar collapse under conditions that no laboratory on Earth could replicate. Yet their scarcity also contributes to their mystique. The fact that such titans exist at all is a testament to the chaotic creativity of the universe. They are fleeting, unstable, and doomed, but while they burn, they outshine nearly everything else. To find one is to glimpse a rare and extreme chapter of the cosmic story, a reminder that the universe delights in pushing boundaries. The horrifying force of Uy Scuti compels us to look beyond science into philosophy. Its enormity and inevitability confront us with uncomfortable truths. What does it mean for human existence that stars can grow so vast, only to die in such violent collapse? What place do we hold in a universe where even giants cannot escape destruction? In contemplating hypergiants, we are forced to accept impermanence. No star lasts forever. No planet, no civilization, no being can resist the entropy woven into the cosmos. And yet, within this inevitability lies meaning. From the deaths of stars come the conditions for new beginnings. From horror comes beauty. From destruction comes life. Perhaps this is the greatest lesson Uy Scuti offers, that even in the face of unimaginable power, we are part of the same cycle. The atoms of our bodies, the ground we stand on, the air we breathe, all are products of stars that lived and died long before us. Uy Scuti, in all its terrifying immensity, is not just a distant monster. It is family. It is the universe's reminder that we are forged from fire, destined to return to it, and that existence itself is both fragile and profound. Studying a star like Uy Scuti is no easy task. Its sheer distance, nearly 9,500 light-years away, makes even the most advanced instruments strain to capture details. Unlike our Sun, whose surface we can study with clarity, Uy Scuti is shrouded in thick layers of gas and dust. Its outer atmosphere is diffuse, more like a mist than a solid boundary, and determining where the star ends and space begins is a matter of definition rather than clear observation. Astronomers rely on a combination of methods, measuring its brightness across different wavelengths, calculating its distance using parallax, and modeling its pulsations. Infrared telescopes are particularly vital, as they can penetrate the dusty veil surrounding the star, revealing structures invisible to the human eye. Even so, uncertainties remain. Estimates of its radius vary, sometimes dramatically, leading to debates over whether Uy Scuti truly deserves the title of largest star. But these uncertainties are not failures, they are opportunities. Every measurement pushes the limits of technology and forces scientists to refine their models. Uy Scuti is not just an object of curiosity, it is a benchmark for our progress in understanding the universe. The very act of trying to define such a monster advances the frontier of human knowledge. Modern telescopes are our windows into Uy Scuti secrets. Instruments like the Very Large Telescope, VLT, in Chile and the Hubble Space Telescope have provided critical data about its size, luminosity, and variability. The European Space Agency's Gaia mission, mapping billions of stars with unprecedented precision, is helping to refine distance measurements, which directly affect size estimates. Newer technologies promise even greater insights. The James Webb Space Telescope, JWST, with its advanced infrared capabilities, is perfectly suited to study stars obscured by dust, like Uy Scuti. By analyzing the spectrum of light, JWST can reveal the chemical makeup of the star's atmosphere, its rate of mass loss, and even the structures of the surrounding nebulae formed from its expelled material. These observations do more than satisfy curiosity. They test the laws of physics under extreme conditions, offering clues about how matter behaves when pushed to its limits. They also prepare us for the day when Uy Scuti, or another hypergiant, finally goes supernova. By studying its present, we gain the tools to understand its future. And, by extension, the violent cycle of birth and death that shapes the cosmos. For now, direct exploration of UY Scuti remains a dream. At nearly 10,000 light-years away, even the fastest spacecraft humanity has ever built would take millions of years to reach it. Still, the idea of studying hypergiants up close tantalizes scientists and storytellers alike. What would it be like to approach a star so vast it could swallow our solar system whole? Future generations may develop telescopes placed far from Earth, on the Moon, in deep space, or orbiting other planets, to gain clearer views of distant giants. Advanced probes, powered by technologies we can scarcely imagine today, might one day send data from the outskirts of such stars. Perhaps we will even build swarms of autonomous instruments capable of mapping their outer atmospheres in detail, watching their death throes unfold in real time. These visions are distant, but not impossible. Humanity has always looked upward, imagining the unreachable and then reaching for it. For now, UY Scuti remains a fiery beacon in the night, studied from afar. But perhaps one day, our descendants will stand at the edge of its swollen atmosphere, staring into the glowing abyss of the largest star ever known, and marvel at the horrifying force of the cosmos. UY Scuti is not only an astronomical wonder, it is also a natural classroom. For scientists and educators, it represents a chance to teach about the laws of physics, the life cycles of stars, and the fragility of cosmic balance. Students learning about nuclear fusion can see in UY Scuti the ultimate example of stellar power pushed to its limits. Concepts like mass, luminosity, and gravity come alive when framed against such an extreme star. The star's very existence highlights the universality of physics. The same principles that allow engineers to design a power plant or build a bridge also govern the titanic furnace of UY Scuti's core. When learners grasp that the rules of thermodynamics and nuclear physics extend seamlessly from Earth to stars 10,000 light-years away, the universe itself feels more connected and comprehensible. Moreover, UY Scuti sparks curiosity. The thought of a star so large it could swallow our solar system forces us to ask deeper questions. Why do stars come in such different sizes? How do they form? What happens when they die? These questions drive science forward. In this sense, UY Scuti is not just a monster, it is a teacher, compelling humanity to confront the grandeur and danger of the cosmos. Throughout history, humans have looked at the night sky and filled it with meaning. Constellations became stories, stars became deities, and celestial events were read as omens. If UY Scuti had been visible to ancient peoples, its sheer dominance in the sky would have inspired myths of titans and gods of fire, its variability interpreted as the heartbeat of some cosmic being. Even in the modern age, hypergiants continue to inspire imagination. Writers, filmmakers, and artists draw on the terrifying scale of stars like UY Scuti to symbolize power, fragility, or apocalypse. In science fiction, such stars often serve as backdrops for civilizations rising and falling, or as engines for futuristic technologies harnessing stellar energy. UY Scuti is a bridge between science and culture. Its very name, whispered in documentaries or written in textbooks, resonates with mystery. Though most people will never look directly at it through a telescope, the idea of its enormity captures attention. It reminds us that the universe is not a cold void, but a stage for awe-inspiring forces that shape not just matter, but the imagination itself. Confronting UY Scuti forces us to reconsider our place in the cosmos. Our sun, so vital to us, is dwarfed into insignificance beside this hypergiant. Our planet, which seems vast to those who live upon it, would be vaporized within its outer layers. Against such immensity, humanity is a whisper, a fragile presence in an indifferent universe. And yet, this perspective is liberating. Recognizing the scale of stars like UY Scuti does not diminish us, it elevates us. For despite our smallness, we are capable of understanding these titans. Our instruments reach across light years, our mathematics describes their behavior, and our imaginations bring their grandeur into the human experience. In a universe filled with overwhelming forces, the act of comprehending them is itself a triumph. Scuti reshapes not just astronomy, but philosophy. It shows us that existence is fragile, yes, but also deeply interconnected. We are children of the stars, born from their ashes, and destined to one day return to them. To study Scuti is to gaze into a mirror that reflects both the terror of annihilation and the wonder of creation. The energy output of Scuti defies comprehension. Every second, it radiates as much energy as our sun produces in weeks. Its luminosity is estimated to be over 340,000 times that of the sun, making it one of the brightest stars ever observed. This staggering energy comes from the relentless process of nuclear fusion in its core, where particles collide under pressures and temperatures so immense that atoms are crushed into heavier forms. For perspective, the entire energy usage of humanity in a year is less than a blink compared to what Scuti produces in an instant. If we could somehow harness even a fraction of its energy, every human need for power could be met 1 billion times over. And yet, this unimaginable power is also destructive. It is the force that inflates the star to its bloated size, drives off its outer layers in violent stellar winds, and prepares the stage for its ultimate collapse. The horrifying part is not just its brightness, but the scale of what such energy means in cosmic terms. Its radiation is capable of sterilizing worlds, reshaping space around it, and igniting new cycles of star birth and death. Scuti is not simply a star. It is a furnace of annihilation, a factory of creation, and a beacon of extremes all at once. Scuti holds the crown as the largest known star by radius, but it is not the only contender in the pantheon of stellar giants. Stars like VY Canis Majoris, Betelgeuse, and Stephenson 2-18 each compete in their own way, whether through mass, brightness, or sheer scale. Stephenson 2-18, for instance, is often cited as possibly being larger than Scuti, though uncertainties in distance measurements make direct comparisons difficult. What matters is not which star is technically the biggest, but that such giants exist at all. Each one pushes against the limits of what physics allows. Beyond a certain point, stars cannot sustain themselves, their atmospheres become unstable, their cores collapse, and they self-destruct. Hypergiants represent the universe's experiments at the edge of possibility, natural demonstrations of what happens when gravity and fusion are pushed too far. Comparing these giants gives astronomers a map of stellar diversity, showing us how different conditions produce different monsters. Scuti is the swollen red hypergiant, Betelgeuse the fiery orange variable, Stephenson 2-18 a possible record breaker. Each has its story, its destiny, and its role in the cosmic balance. Together, they reveal the terrifying range of scales that stars can reach. The death of a star like Scuti does not end with its own destruction. Its explosion sends ripples across the galaxy, triggering chain reactions that reshape space on massive scales. The shockwaves from its supernova will compress nearby gas clouds, igniting the birth of new stars. In this way, the death of one titan may lead to the creation of dozens, or even hundreds, of smaller suns. These new stars, in turn, may form planetary systems. Some of those systems might one day harbor life, civilizations, and stories of their own. In essence, the horrifying force of Scuti's end is also the seed of future beginnings. Its destruction is not final but transformative, weaving new threads into the cosmic tapestry. The heavy elements produced in its explosion will also enrich the interstellar medium. Gold, uranium, and other rare materials will be scattered across light years, waiting to be incorporated into future planets. Without such events, there would be no Earth, no oceans, no human beings. Hypergiants like Scuti may terrify us, but they also ensure the continuity of cosmic evolution. Their deaths are not isolated tragedies, they're galactic rebirths. As horrifying as Scuti is, it is not the ultimate monster of the cosmos. When compared to black holes or quasars, its might seems almost fragile. Black holes, the remnants of collapsed giants, are gravity incarnate, swallowing light itself. Quasars, powered by supermassive black holes in distant galaxies, outshine trillions of stars combined. And yet, Scuti stands apart because it is alive, a living furnace still burning with colossal fury. Where black holes are silent predators, Scuti is a roaring beast, visible across the galaxy, devouring its own fuel in a desperate blaze. Its energy radiates outward, flooding its surroundings with light and matter, unlike the cold hunger of a black hole. This comparison reveals a chilling truth: Scuti is part of a chain. Giants like it collapse into black holes, which in turn shape galaxies, fueling quasars and dictating the flow of cosmic matter. In studying Scuti, we are not just learning about a single star, we are peering into the origins of the universe's greatest predators. Its horrifying size is not an endpoint but a step toward something even more incomprehensible. When we look at Scuti, we are not seeing it as it is now. We are seeing it as it was nearly 9,500 years ago. The photons striking our telescopes tonight left the star before the pyramids of Egypt were built, before human civilization took root, before recorded history even began. For all we know, Scuti may already be gone, collapsed, exploded, or transformed, and we are simply waiting for its death to reach us. This time delay is one of the most haunting aspects of astronomy. Every star we see is a ghost of its past, frozen in a snapshot from long ago. For nearby stars, the delay is small, a few years or decades. But for Scuti, the delay spans millennia. By the time we witness its final explosion, entire civilizations may have risen and fallen on Earth. The horrifying part is the uncertainty. At any moment, the light of its supernova could arrive, dazzling the night sky. Or it may not come for hundreds of thousands of years. To live beneath the stars is to live with this constant reminder of our place in time. Fragile beings watching echoes of a universe that may already have changed beyond recognition. When Scuti finally dies, its presence will not vanish. The nebula it leaves behind will shine for tens of thousands of years, a glowing scar in the Milky Way. The heavy elements forged in its core will drift across the galaxy for billions of years, incorporated into new stars, new planets, and perhaps even new life. Its black hole remnant, if one forms, will persist for trillions of years, long after every ordinary star like our Sun has burned out. In this way, Scuti's legacy is eternal. Though its bloated body will perish, its essence will ripple across cosmic history. It may shape worlds that do not yet exist, worlds whose skies will one day be looked upon by beings who wonder, as we do, about the monsters that came before them. From horror comes continuity. From annihilation comes renewal. Scuti, the terrifying hypergiant, will live on in fragments scattered through the galaxy. Every star that shines in the night sky is a reminder of this truth: nothing in the universe truly ends. It only transforms. To fully appreciate the horrifying force of Scuti, imagine if Earth were not thousands of light years away, but within its immediate neighborhood. Even at a distance of a few dozen light years, our planet would face catastrophic consequences. The star's intense radiation would overwhelm Earth's protective magnetic field, stripping away the atmosphere over time. Our oceans would boil, the surface would be sterilized, and the biosphere would collapse into silence. If Earth orbited Scuti directly, survival would be impossible. The planet would be deep inside the star's swollen outer layers, vaporized into plasma and absorbed into its body. No solid ground, no sky, no air, only the crushing embrace of stellar fire. Even planets as far as Jupiter's orbit would not escape. Entire systems would be swallowed whole, reduced to debris in the belly of a giant. This thought experiment is terrifying not just for its scale but for its realism. Stars like Scuti are not hypothetical. They exist, and many may have swallowed their own planets already. Somewhere in the galaxy, worlds that once bore oceans and continents may have been consumed by giants just like this one. Scuti reminds us how fragile the balance of our solar system is, and how fortunate we are to orbit a star that sustains, rather than destroys, life. Though Uy Scuti itself is invisible to the naked eye, the concept of stellar giants has always haunted human storytelling. Ancient civilizations personified the brightest stars as gods of war, agriculture, or destiny. If they had known of a star large enough to swallow worlds, it surely would have been immortalized as the embodiment of destruction and rebirth. In modern times, hypergiants inspire a new kind of myth, one shaped by science and imagination. In literature and film, stars like Uy Scuti often serve as symbols of apocalypse or transcendence. They embody both fear and fascination, standing as reminders that the universe dwarfs all human ambition. Their presence in cultural narratives reflects a deeper truth: humanity has always needed giants, whether in the form of gods, monsters, or stars, to remind us of our limits and inspire us to push beyond them. Uy Scuti, though a distant astrophysical object, becomes part of this lineage. It is not just a number in a catalogue, it is a story we tell ourselves about scale, mortality, and wonder. By naming it, studying it, and imagining its fate, we weave it into the fabric of human culture, just as we have done with stars for millennia. In many ways, Uy Scuti can be seen as a symbol of humanity's future among the stars. As we dream of colonizing space and traveling beyond our solar system, we will inevitably encounter the extremes of the cosmos. Stars larger, brighter, and deadlier than anything we have experienced. Hypergiants will be both obstacles and opportunities, obstacles because of their destructive power, and opportunities because of the resources they spread across the galaxy. The elements we need to build starships, terraform planets, and sustain civilizations may come from the ashes of stars like Uy Scuti. Its terrifying death will seed the galaxy with the raw materials of future exploration. In that sense, our destiny is intertwined with the lives and deaths of hypergiants. Uy Scuti also reminds us that survival requires humility. We are small, fragile creatures living in a universe of giants. To thrive, we must learn to respect the forces that dwarf us. Our future will not be built by conquering the stars, but by understanding them, by learning to live within the rhythms of their creation and destruction. Uy Scuti, in all its horror, is also a guide. One of the most unsettling aspects of stars like Uy Scuti is their unpredictability. While astronomers can model their life cycles, the precise timing of their collapse remains uncertain. A hypergiant may appear stable for centuries, only to suddenly brighten, dim, or shed massive amounts of material without warning. These fluctuations, caused by internal instabilities and chaotic energy flows, are signs of a star teetering on the edge of destruction. Betelgeuse, another nearby red supergiant, demonstrated this unpredictability when it dimmed dramatically in 2019, leading many to speculate it was about to explode. It didn't, but the event reminded scientists that even the most advanced models cannot yet fully predict when a giant will die. Uy Scuti, far larger and more unstable, is an even greater mystery. For all we know, it could collapse tomorrow, or it could persist for another 100,000 years. This uncertainty is part of what makes hypergiants so horrifying. They are ticking bombs with hidden timers, their deaths inevitable but their timing unknowable. Living in a galaxy with such stars means that cosmic catastrophes are not just theoretical, they are guaranteed. The only question is when, and where, the next detonation will light up the night. Studying Uy Scuti and its kin does more than reveal the fate of modern stars, it provides a window into the early universe. Billions of years ago, the first stars, known as population 3 stars, were even larger and more unstable than today's hypergiants. Composed almost entirely of hydrogen and helium, they lived for only a few million years before collapsing into black holes or exploding in cataclysmic bursts. Though those ancient giants are long gone, their influence remains. They seeded the young universe with the first heavy elements, laying the groundwork for galaxies, planets, and eventually life. By observing hypergiants like Uy Scuti, scientists can approximate what those primordial stars may have been like. Their short lives, violent deaths, and massive influence echo the same story written billions of years ago. In this sense, UY Scuti is more than a modern phenomenon, it is a living fossil of cosmic processes that shaped everything we know. To study it is to look backward in time, glimpsing the forces that sculpted the first galaxies. Hypergiants bridge the gap between our universe's fiery infancy and its present complexity. They are both relics and active participants in the grand story of creation. No matter how large, luminous, or terrifying, every star must eventually die. For UY Scuti, the path leads to collapse, explosion, and perhaps the birth of a black hole. But in the grand sweep of cosmic time, even black holes are not eternal. Over trillions upon trillions of years, even they will evaporate through Hawking radiation, fading into the darkness of an expanding universe. In this way, UY Scuti's legacy will stretch far beyond its fiery death. Its elements will persist in stars and planets for billions of years, its possible black hole remnant for quadrillions, and the echoes of its energy will ripple into the deep future of the cosmos. Yet even this is temporary. In the end, entropy spares nothing, not stars, not galaxies, not even black holes. What is horrifying about UY Scuti is not only its scale, but its reminder that impermanence is universal. Even the greatest monsters of the cosmos cannot escape the slow march of time. And yet, there is beauty in this as well. In its death, UY Scuti will join the endless cycle of transformation that defines the universe. It is both fleeting and eternal, destructive and creative, horrifying and sublime. From the moment humans first lifted their eyes to the heavens, stars have been sources of mystery and wonder. UY Scuti, though discovered only in the 19th century and properly measured in the 20th, is the culmination of that quest, an object so vast and extreme that it stretches the boundaries of imagination. To study such a star is to test not only our technology but also our determination to seek truth in the face of enormity. Astronomers dedicate lifetimes to gathering fragments of light from UY Scuti, converting those faint signals into knowledge. Each new measurement of its pulsations, its spectral fingerprint, its changing brightness, is a step closer to understanding its nature. Humanity cannot alter UY Scuti's destiny, nor can we protect ourselves from stars like it, but we can witness and learn. That is our power. The quest to understand giants like UY Scuti is not just about astronomy. It is about identity. By uncovering the secrets of such monsters, we are reminded that our species is capable of comprehension, even when faced with the incomprehensible. This pursuit affirms our place in the cosmos, not as rulers, but as storytellers, scientists, and explorers. The study of hypergiants has pushed technology forward in ways few realize. To measure a star like UY Scuti, scientists developed ever more powerful telescopes, sensitive detectors, and advanced computing models. These tools, in turn, have applications far beyond astronomy, in medicine, imaging technologies, data analysis, and even communications. The pursuit of understanding UY Scuti is a reminder that curiosity drives innovation. Our need to see deeper into space leads to breakthroughs that improve life on Earth. The detectors used to analyze faint starlight, for example, have also been adapted for use in hospitals, where they help scan human bodies with astonishing precision. Algorithms designed to process astronomical data are now used in climate science, engineering, and artificial intelligence. In this sense, UY Scuti has already shaped humanity, not by its distant light, but by the challenge it presents. To study something so immense forces us to think bigger, invent more, and expand the limits of what technology can achieve. The terrifying star is, paradoxically, a silent benefactor, fueling progress without ever knowing it. Perhaps the most striking aspect of UY Scuti is the tension it embodies between fear and wonder. On one hand, it is horrifying, a swollen behemoth that could swallow planets whole, destined to explode with the force of billions of nuclear bombs. On the other, it is awe-inspiring, a cosmic furnace forging the very elements of life, a beacon of beauty shining across thousands of light-years. This duality is at the heart of humanity's relationship with the cosmos. We fear the unknown, but we are also drawn to it. We are humbled by the scale of stars like Uy Scuti, yet we celebrate our ability to understand them. In its enormity, Uy Scuti becomes more than a star, it becomes a mirror of ourselves, reflecting our fears, our aspirations, and our capacity for wonder. In the end, the horrifying force of the largest star ever discovered is not a story of destruction alone. It is also a story of connection. Uy Scuti reminds us that even in the face of unimaginable power, we are part of the same universe, bound by the same laws, and made of the same stardust. Horror and beauty are inseparable, and together they define our cosmic story. Galaxies are not static star fields, they are ecosystems, constantly recycling matter through birth and death. Hypergiants like Uy Scuti are among the key drivers of this cycle. Their violent stellar winds enrich interstellar space with elements, and their supernovae inject shockwaves that compress clouds of gas, triggering new generations of stars. Without them, galaxies would wither into quiet collections of dim suns, lacking the dynamism that makes them vibrant. The Milky Way's very structure has been influenced by waves of stellar deaths over billions of years. Massive stars create bubbles and cavities in the galactic medium, reshaping the flow of matter and energy. Hypergiants, though rare, are the most potent contributors to this process. They are not isolated phenomena but active participants in the balance of creation and destruction that sustains galaxies. In this sense, Uy Scuti is not only terrifying, it is essential. Its death will one day carve new regions in the galactic arm, spark new clusters of stars, and spread the ingredients for life across thousands of light-years. Though its collapse will be catastrophic, its echoes will sustain the Milky Way long after the star itself has vanished. When we imagine Uy Scuti, we do so from the vantage point of Earth. But what if there are civilizations scattered across the galaxy, living closer to this monster? To them, Uy Scuti would not be an abstract object catalogued by astronomers, it would dominate their skies. Its massive, pulsating glow might outshine every other star, shaping their myths, their science, and even their sense of mortality. For a civilization within a few dozen light-years, Uy Scuti's eventual death would be an existential threat. They may spend centuries dreading the arrival of the shockwave, perhaps building stories or even technologies to shield themselves from its effects. To others, farther away, its supernova might appear as a glorious spectacle, studied and revered as one of the great cosmic events of their age. The alien perspective forces us to realize that the universe is not ours alone. Uy Scuti's destiny will ripple outward, affecting not just matter but potentially the lives and cultures of beings we have yet to meet. To us, it is a horror we observe from safety. To others, it may be a looming apocalypse, or the source of myths that echo through their civilizations. Imagine humanity thousands of years from now, traveling among the stars. By then, Uy Scuti may already have exploded, its light blazing through the skies of Earth and distant colonies alike. Future historians and storytellers may recount the moment as a milestone in cosmic history, the death of one of the largest stars ever known, witnessed across the galaxy. Perhaps future humans will sail through the nebula left in its wake, harvesting the enriched elements scattered by its explosion. They may mine its black hole remnant for energy, or simply record it as a monument to the scale of creation. Children on distant worlds may learn the name Uy Scuti the way we now learn of dinosaurs or ancient empires, as a symbol of the power and fragility of nature. Even if humanity is gone, replaced by other beings, the story will remain. The remnants of Uy Scuti will speak for themselves, written in gas clouds, black holes, and enriched stars. Its horrifying force will echo across cosmic time, ensuring that no civilization, no matter how advanced, can ignore the legacy of giants. There is something profoundly poetic about Uy Scuti. Despite its horrifying scale, its immense power, and its looming death, it is ultimately a fleeting phenomenon. In the cosmic timeline, millions of years is a heartbeat. Uy Scuti burns brightly now, but soon it will collapse, vanish, and leave only echoes. Its impermanence is what makes it beautiful, a cosmic firework, dazzling and terrifying, before fading into memory. This impermanence mirrors our own existence. Just as Scuti is brief compared to the life of the galaxy, so are human lives brief compared to history. And yet, like the star, we burn brightly in our moment, shaping the world around us, leaving behind fragments of ourselves in culture, science, and legacy. Scuti reminds us that nothing, no matter how immense, escapes change. Mountains erode, planets perish, stars collapse. Yet from this cycle comes continuity. It is precisely because things end that new things begin. The poetry of impermanence is the poetry of transformation, a truth woven into both human lives and cosmic scales. Hypergiants like Scuti teach us about survival, not through their endurance but through their failure. Their lives are warnings written in fire: grow too large, burn too fast, and collapse is inevitable. For civilizations, the lesson is clear: balance sustains, excess destroys. The sun, with its moderate size and steady fuel consumption, is the reason Earth has thrived for billions of years. Scuti, in contrast, is the cautionary tale of imbalance. On a practical level, studying stars like Scuti prepares humanity for cosmic hazards. Supernovae and gamma-ray bursts are threats that could sterilize planets. By understanding the mechanics of hypergiants, we may one day predict such events with precision, giving future civilizations time to shield themselves or migrate to safer regions. Survival in the cosmos depends not on ignoring dangers but on anticipating them. Scuti is a terrifying reminder that the universe is filled with forces capable of erasing us in an instant. But it also gives us knowledge, the first tool in our survival kit. In its fury, it teaches us caution. In its death, it offers us resources. In its story, it whispers the lessons of endurance. At its heart, the story of Scuti is about scale. A single star, thousands of times larger than our Sun, capable of swallowing planets, altering galaxies, and shaping the course of creation. Its horrifying force is a mirror of the universe itself, vast, indifferent, powerful beyond comprehension. And yet, it is also fragile, fleeting, and destined to die. The final lesson of Scuti is humility. We are small, but we are aware. We are fragile, but we endure through knowledge. Unlike the star, we are not bound to a single destiny. While Scuti must collapse, humanity can adapt, change, and evolve. In this difference lies our hope. Scuti shows us that even the greatest giants cannot last forever. But it also shows us that from their ashes comes renewal. The gold in our veins, the calcium in our bones, the iron in our blood, all are gifts from ancient stars that lived and died like Scuti. We are their legacy, just as future beings will be the legacy of this hypergiant. Horror and wonder, destruction and creation, death and life, all bound together in one star. When we step back and consider hypergiants as a whole, we see more than astronomical curiosities, we see the architects of destiny. Stars like Scuti live fast and die young, but in doing so, they reshape galaxies, enrich the cosmos with the building blocks of complexity, and light the way for future generations of stars and worlds. Their legacy is written not only in the heavens but also in us. Every breath we take is a testament to their work. Oxygen, forged in stellar furnaces, fills our lungs. Iron, hammered out in supernovae, pulses in our veins. Even the rare elements, gold and platinum, are cosmic relics scattered by these monsters. Hypergiants are the cosmic parents of everything familiar, and Scuti is among their most extreme children. This legacy is terrifying because of the scale of destruction required to create it. But it is also profound. Without death, there is no life. Without collapse, there is no renewal. Scuti, in its inevitable demise, continues the cycle that binds the universe together. Its horrifying force is not wasted. It is transformed into the fabric of tomorrow. Our fascination with Scuti is not accidental. It speaks to something deep within the human spirit, the need to know where we come from and how we fit into the universe. Standing on Earth, we are dwarfed by stars like this one. But through science, we claim a kind of kinship with them. By understanding their nature, we understand ourselves. Scuti becomes part of our identity as a species. We are the children of stars, built from their ashes, destined to return to the same cycle. Knowing this gives weight to our existence. We are not separate from the cosmos, we are its expression. Our stories, our cultures, our lives are all chapters in a book written by stars that lived and died long before us. In this way, Scuti humbles us and elevates us at once. It reminds us of our fragility, yet it also shows us that we are the universe aware of itself. To comprehend a hypergiant is to bridge the gap between atoms and infinity, between mortality and eternity. That is humanity's cosmic identity, small, fleeting, but capable of seeing the grand design. As we near the end of Scuti's story, we see more than a star. We see a symbol of the universe's extremes, a beacon of both horror and beauty. Its swollen body reminds us that size does not guarantee strength. Its ticking clock reminds us that nothing lasts forever. Its eventual collapse reminds us that even destruction has meaning in the cosmic order. For humanity, Scuti is both warning and inspiration. It warns us that the cosmos is not gentle, that survival requires humility and foresight. But it also inspires us to seek knowledge, to push beyond the limits of imagination, and to embrace our place in a universe shaped by cycles of fire and renewal. When its light finally reaches us, whether tomorrow or in 100,000 years, we will witness one of the greatest shows the cosmos has to offer. And in that moment, we will be reminded that we are part of this universe, born from its chaos, alive in its brief calm, and destined to return to its fire. To truly grasp the horrifying force of Scuti, one must embrace perspective. Our entire solar system, with its planets, moons, and asteroid belts, could fit inside its swollen body. Earth itself, the cradle of human history, would be nothing more than a grain of dust dissolved in its plasma. The sun, the very star that sustains us, would appear as a flickering ember beside this leviathan. This perspective is humbling to the point of terror. Everything we know, every achievement of humanity, would vanish unnoticed within such a star. Our civilizations, our monuments, even the memory of our species would mean nothing to the fury of Scuti's gravity and fire. It is a reminder that the universe is not built for us, nor does it bend to our will. And yet, in facing this truth, we find strength. Horror becomes awe. Insignificance becomes clarity. To confront Scuti is to acknowledge the scale of the cosmos and still declare, we exist, we endure, and we seek to understand. That, perhaps, is humanity's quiet defiance against the vast indifference of the stars. Though Scuti is destined to collapse, its death is not an ending but a gift. The elements it will scatter across space may one day form new stars, new planets, and perhaps even new life. Somewhere in the galaxy's distant future, beings may walk on worlds enriched by the dust of this hypergiant, unaware that their existence is tied to a monster that once burned with horrifying force. This cycle gives meaning to destruction. The star's terrifying fate is the same fate that gave us the resources to build cities, craft tools, and ask questions about the cosmos. Every heartbeat, every thought, every dream is a legacy of ancient stars that died before Earth was even formed. Scuti will join that lineage, its fiery death ensuring the continuity of life elsewhere in the galaxy. Hope is hidden in fire. Horror gives way to beauty. The universe, through stars like Scuti, writes a story of endless renewal, and humanity is both reader and participant in that story. Picture the night sky, thousands of years from now. A brilliant light flares in the constellation of Scutum, outshining all other stars, even visible under the midday sun. It is Scuti, announcing its death in a blaze that will echo across the galaxy. For weeks, the heavens glow with its fury, a beacon of both annihilation and rebirth. Astronomers will record the event with instruments more powerful than we can imagine. Poets will write of it, artists will paint it, civilizations will mark the moment as a turning point in history. Long after the light fades, the nebula of its remains will shine, a ghostly monument to what once was. And buried at its heart may lie a black hole, silent and eternal, the final remnant of the largest star ever discovered. In that vision lies the essence of Uy Scutai's story. Horror and wonder entwined. Destruction and creation inseparable. A single star, larger than imagination, shaping galaxies and destinies through its life and death. And as we look up, we are reminded of our place, fragile beings, forged from stardust, daring to understand the monsters of the cosmos. That is the legacy of Uy Scuti. That is the horrifying force of the biggest star ever discovered. When Uy Scuti finally detonates, the galaxy will hear its roar in light and radiation. But afterward, silence will fall. The star that once blazed across the heavens will be gone, replaced by darkness where once there was brilliance. The silence of a collapsed hypergiant is almost more haunting than its life. One moment, it is the most powerful object for thousands of light years, the next, it is nothing but a remnant hidden in shadows. This silence is not emptiness, though. It is a stage reset. The nebula glowing faintly where the star once lived is the whisper of creation, announcing that the cycle continues. In time, the silence will give way to the faint stirrings of new stars and worlds. Uy Scutai's absence becomes its presence, proof that nothing in the cosmos truly ends without leaving a trace. If Uy Scuti collapses into a black hole, it will leave behind the most fitting tombstone imaginable, an abyss that swallows everything nearby. A black hole is not only the death of light but the triumph of gravity, a point where the universe itself bows. This remnant would outlast stars, civilizations, and even galaxies. For trillions of years, long after ordinary suns have faded, Uy Scutai's black hole may still persist, a silent reminder of the giant that once was. In that sense, Uy Scutai's grave is eternal. Unlike pyramids or monuments built by human hands, which erode with time, its final mark will be carved into the very fabric of space-time. To gaze into such a remnant is to see the shadow of a star that was once the largest known. It is both horrifying and humbling, proof that even the greatest giants are reduced to silence, yet their silence is monumental. When distant civilizations, human or alien, one day look back on Uy Scuti, they will see more than a collapsed star. They will see a lesson written in fire. The lesson that scale alone does not mean stability. The lesson that brilliance often comes with fragility. The lesson that creation and destruction are inseparable twins. Future scientists may study the nebula of its remains, analyzing the fingerprints of heavy elements that seeded their own worlds. Philosophers may write of its paradox, a monster that killed with its death but gave life with its ashes. Teachers may use it as a story of humility, warning students of the limits of power. Every civilization needs its giants to remind it of scale. Uy Scuti is one of ours, a symbol that will persist even after the star itself is gone. It is the reminder that survival, whether of stars or species, depends on balance, not excess. Uy Scuti is more than a star, it is a definition. It defines the upper limits of stellar size, the extreme of what matter can achieve before collapsing under its own weight. It defines the fragility of giants, the inevitability of destruction when balance is lost. It defines the terrifying beauty of the universe, where the same forces that erase worlds also make life possible. Every field of science thrives on its extremes, the fastest, the hottest, the coldest, the biggest. Uy Scuti occupies that role for astronomy. It is the record breaker, the monster, the benchmark against which all other giants are measured. Its horrifying force is not just physical but symbolic, a reference point for our imagination. And when it is gone, we will still speak of it. Its name will remain in the annals of astronomy, in documentaries and classrooms, in myths of future civilizations. The star that defined the extreme, and through that definition, defined us. Stars like Scuti act as mirrors for humanity. In their light, we see not only nuclear fusion and astrophysical equations but reflections of ourselves. Its vastness reminds us of our smallness. Its fragility reminds us of our mortality. Its role as a creator of elements reminds us of our origins. When we study Scuti, we are not only exploring the universe, we are peering into our own nature. The mirror it holds up is harsh but honest. Power does not guarantee permanence. Brilliance comes at a cost. Even the largest and brightest are bound to fall. These truths apply as much to human civilizations as they do to stars. Empires rise, expand, blaze, and eventually collapse, leaving behind the seeds of what comes next. In Scuti's fire, we see echoes of our own story. Every star is a balancing act between gravity and radiation. Scuti shows us what happens when the scales are tipped too far toward brilliance. Its bloated atmosphere, its furious winds, its unstable pulsations, all are symptoms of imbalance. It is a star stretched to breaking point, unable to sustain the delicate harmony that smaller, steadier stars like our Sun maintain. This balance extends beyond stars. Planets must orbit at the right distance for life to thrive. Ecosystems must maintain equilibrium to survive. Civilizations must balance ambition with sustainability. In this sense, Scuti is not only a celestial object but also a cautionary tale. Its collapse is the cosmic equivalent of excess unchecked, a reminder that survival comes not from extremes, but from harmony. Humanity has built monuments, cathedrals, skyscrapers, and machines. Yet all our creations are dwarfed by Scuti's effortless power. Its surface outshines every city combined, its heat dwarfs every furnace we've ever built, its winds carry away more material in a day than we could mine in 1,000 lifetimes. Against such scale, human effort feels small. And yet, there is something remarkable here. While Scuti burns blindly, unaware of its magnificence, we can understand it. That is humanity's quiet triumph. The star may outshine civilizations, but civilizations can describe the star. Its horrifying immensity does not silence us. It inspires us to speak, to calculate, to tell its story. In this way, we surpass it, not in size, but in awareness. Every photon emitted by Scuti carries a piece of its story. Traveling across the void for thousands of years, those photons arrive at Earth as faint glimmers in the night sky or as data captured by telescopes. They tell us of fusion in its heart, of gases in its atmosphere, of the colossal size of its body. Light is the language of the stars, and Scuti speaks it with terrifying brilliance. To study those photons is to read a story older than our civilization. The light we see tonight left the star before humans invented writing, before the wheel, before agriculture spread across the earth. It traveled across time to deliver its message. This is what a giant looks like. One day, its final photons will arrive, bearing news of its collapse, completing the story. Until then, we wait, readers of a tale written in fire and carried on beams of light. Scuti may be the largest known star, but it is not alone. Across the galaxy and beyond, other hypergiants swell, blaze, and collapse. Each is a variation on the same theme, cosmic excess leading to cosmic destruction. Stevenson 2-18, V. Canis Majoris, Betelgeuse, names that echo like titans in an ancient saga. Together, they form a gallery of monsters, each testing the limits of what stars can be. To know Scuti is to know that we live in a universe of extremes. It is not a quiet, gentle place but one where fire, gravity, and time battle endlessly. Giants rise, burn out, and fall, while smaller stars endure in the background. The existence of such diversity is proof of the cosmos' boundless creativity and its boundless indifference. Though Scuti feels impossibly distant, we are intimately connected to it. The carbon in our cells, the calcium in our bones, the oxygen we breathe, all forged in stars like this one. We are walking evidence of stellar death. In every heartbeat, we carry the memory of giants that lived and perished billions of years ago. This connection transforms horror into gratitude. Yes, Uy Scuti is terrifying. Yes, its death will be catastrophic. But without stars like it, there would be no planets, no oceans, no life. Its horrifying force is the reason we exist at all. To reject its violence is to reject our own origin. To embrace it is to embrace the truth: we are children of fire. In the grand play of the universe, Uy Scuti is a brief but unforgettable actor. Its role is to demonstrate excess, to show what happens when a star grows too vast, and to end in a display so violent that it reshapes its surroundings. The stage it performs on is not just its constellation, not just the Milky Way, but the universe itself. Its death will be visible for light years in every direction, its influence felt for eons. And yet, it is only one actor in a cast of billions. The stage goes on, the play continues, and new stars rise to take its place. The cosmic drama is endless, but each star, each explosion, each collapse adds its chapter. Uy Scuti's chapter may be horrifying, but it is also unforgettable, the story of a giant that defied comprehension and left a legacy written in both light and shadow. For now, Uy Scuti remains in the sky, bloated and unstable, its clock ticking silently toward collapse. We do not know when the finale will arrive, tomorrow, or in 100,000 years. But we do know what will happen: fire, brilliance, silence, rebirth. The script is written, even if the timing is not. And so we wait. We build telescopes to watch, we write stories to imagine, we prepare ourselves for the day its light reaches us with news of its death. Whether humanity survives to witness it or not, the finale will come. The universe does not delay its climaxes for us. It unfolds in its own time. Waiting for Uy Scuti's explosion is like waiting for a cosmic drumbeat, distant, inevitable, and overwhelming. And when it arrives, it will remind us of everything we already know but often forget: that we are fragile, that we are temporary, and that we are, nonetheless, part of the stars. In the end, Uy Scuti is not merely a star. It is a symbol. A symbol of excess and fragility, of horror and beauty, of death and creation entwined. It is the reminder that even the greatest giants cannot escape collapse, and that from their ashes comes renewal. Its horrifying force is not only a threat but also a promise, the promise that the universe, through destruction, creates again. As we gaze into the night sky, we see not only distant lights but ancient stories. Uy Scuti's story is one of the grandest, a tale of fire that outshines imagination, a death that will shake galaxies, and a legacy that will echo for eternity. And so, we close with this truth: we are stardust, watching the stars. The atoms of our bodies are the children of giants, and someday, the light of Uy Scuti's death will reach us, carrying the final chapter of its tale. When that moment comes, we will witness both horror and wonder fused into one, the last breath of the largest star ever discovered. This was the horrifying force of Uy Scuti, the cosmic giant whose life and death remind us of our place in the universe, small, fragile, and yet capable of understanding the very stars that gave us life.